Hello, today I will discuss weighted IMGM, which tells us that if we are given n numbers a1, a2 up to an, all of them are non-negative, and lambda 1, lambda 2, lambda n, their sum is 1 and they are also non-negative, then we can see that lambda 1 times a1 plus lambda 2 times a2 all the way up to lambda n times an, this is greater or equal product of ai times lambda I, the I is from 1 to n. Today I will consider two different proofs. The first one will be about the case then lambda is some number m1 over lambda 1 is m1 over m1 plus m2 plus all the way up to mk. Clearly we can represent all numbers lambda 1, lambda 2 and lambda n if they are rational numbers in this term, like lambda I will be mi over sum of the integers from m1 plus m2 all the way up to mk. If you got any question why we can represent this like this one, please write in the comments and I will try to explain this more clearly. So in this case we will have m1 times a1 plus m2 times a2 all the way up to mn times an, and this number is divided by m1 plus m2 all the way up to mn. Now we can see that we can represent these numbers as a1 m times plus a2 m2 times, and the last one will be an mn times. Now if we use common AMGM for these numbers, then we need to divide these by their average, so their number is m1 plus m2 plus mn. Clearly this is greater or equal to their geometric mean, and their geometric mean is m plus m1 plus m2 plus all the way up to mnth root from their product, and that is their product a1 to the m1 power times a2 to the m2 power all the way up to an to the mn power. But if we expand this one, we will get a1 to the m1 over m1 plus m2 plus all the way up to mn. Similarly for every numbers, and for an it will be mn over this common sum, and this number is equal to lambda 1 and last two number equal to lambda n. So this was all we wanted to show. So we have proved weighted IMGM inequality for rational numbers. And how can we prove this for every numbers? Now we need to use another inequality. This is called Jensen inequality, and for this case we need to take a logarithm to both sides. Ln of, we will have ln of these numbers ai times lambda I. This must be greater or equal lambda I times sum of lambda I times ln I. And now we need to use the fact that ln x is a concave function. This means that ln x second derivative must be positive. What is ln x derivative? This number is 1 over x, and what can we say about the 1 over x derivative? This number is clearly negative 1 over x squared, and this number is always negative for every x greater than 0. This means that if the second derivative is negative, this means that the function is concave. And for concave function, we know that by using Jensen inequality, this is always correct, that minimum will be attained when we take their minimum, sum of the minimum. So we have proved for every numbers a1, l1, a1 and w1 that this number will be always greater than the second side. I know that Jensen is very difficult inequality to understand, so I will link this inequality and I will try to discuss this later after I discuss the derivatives and some theorems in the students' Olympiads. If you got any questions, please write in the comments, and I will also link 2020 IMO second problem, which can be solved by using weighted dimension very easily. So if you know weighted dimension, this will be very useful for the Olympiads, especially like IMO and other international Olympiads.